This is They Create Worlds, episode 130, Uncle Clive's Radionics.
If anybody wants to find me, I'll be in the last place you would look. In a place where people used to be, a land that's called reality. You'll find me there.
Welcome to They Create Worlds. I'm Jeffrey, and I'm joined by my co-host, Alex.
Hello.
Once again, we get to go over the ocean, the wonderful land of Great Britain, where we get to learn all about the ZX Spectrum and its wonderful inventor, Uncle Clive.
Well, slow down there just a little bit, Jeff, because this is They Create Worlds, and we do get to talking, by which I mean to say I get to talking, so I don't think there's going to be any ZX Spectrums in this particular episode. However, this is certainly, as you indicated, part one of what will be a two-part look at Sir Clive Sinclair and the companies that he owned over the years. This episode is actually going to be entirely background. We're only going to get to the very, very beginning of his period in the computer business, because really to understand what exactly Uncle Clive was doing in the computer business and how he felt about the computer business and where he saw the computer business fitting into his larger ambitions, you really have to understand his entire history and the history of his companies, which go back a good 20-plus years before they released the ZX80, which was not the first computer, but was the first kind of significant computer they released. Sir Clive is someone who was enamored by electronics, was definitely enamored by trying to push electronics forward into a new and glorious future, but computers were not actually really his thing. It was a sideline. It was something he did when other parts of his business were struggling. As we will see over the course of this two-parter that we're going to do here, despite how Uncle Clive himself might have felt about computers, they definitely ended up being his lasting legacy, or at least his lasting positive legacy. He has a couple of negative legacies, one of which we will also go into later in this episode. Certainly, he was as responsible as anybody in creating an atmosphere where a incredibly vibrant, incredibly innovative, and unique computer game environment could flourish in the United Kingdom for a decade and a half or so before it kind of got sucked into the wider global trends of the industry.
So obviously, since he's referred to as Sir Clive, he's been knighted by the Queen.
Correct.
He has this sort of affectionate nickname of Uncle Clive. So I'm really interested to understand how all of that came about. Obviously, the knighthood came from his great dedication with computers and technology and popularizing it in England and Great Britain.
Absolutely.
Where exactly did the Uncle Clive thing come from?
It had a lot to do with his personality and the way he carried himself and how he kind of appears. Clive Sinclair is a true technology nerd. One would even often describe him as a bit nebbish, which is really not a nice way to refer to somebody, but it's another way of referring to someone that is very kind of smart but withdrawn and insular. He just always came across, just the way he looked, the way he talked, very soft-spoken. He always kind of came across as somebody who was almost one of the blokes, but was a little bit apart. You know, is kind of that nerdy kid in class, or, you know, that one uncle, let's say, that you would only see on holiday, who would always come and bring you some technological thing he'd been fiddling with in his garage or something like that. It was about how he was kind of not so much seemed like a businessman, but seemed like somebody who was just kind of genuinely nerdy and enthusiastic about this technology and that kind of thing.
All right, so where do we want to start off? Obviously not the childhood and all of that fun thing. Did he get into technology during his teenage years? Did he get into technology later on in life or as an early career? Where do we want to start with all this?
Sure. So technology was something that was lifelong for him, and he came by it quite honestly. Both his father and his grandfather were engineers. His grandfather was a shipbuilding engineer. His father had actually had aspirations to become a minister. His grandfather kind of said, well, you can go off and do that, but why don't you get a degree first, and then if that doesn't work out, you have something to fall back on. He ends up not becoming a minister, and he's a mechanical engineer himself as well. He literally grew up surrounded by engineers. It was definitely in his genes. He was a math prodigy. At the age of 10, his primary school told him that there was no more they could teach him in math, and it was time for him to begin his secondary education, what we in the United States would call high school. He started high school math at 10 years old because he was just that far ahead of everybody. He became very enthusiastic about electronics during his teenage years. One thing that kind of set him apart, and one thing that would define his entire career in electronics, is he wasn't just interested in building things. He wasn't just interested in combining circuits in new and ingenious ways, but he was obsessed with miniaturization, making things smaller and better at the same time, getting the circuits as tiny as possible, getting as many circuits into something as possible. That was kind of his overriding goal with electronics. He was a circuit designer from a very young age. I mean, he wasn't just interested in, as some kids are, in sending off for a kit and soldering all the parts onto the board. He wanted to design the circuits himself, even when he was a teenager. He truly was a prodigy when it came to electronics. He kind of shuffled off to do his A-levels at St. George, but he didn't really want to continue education. He was very smart. He was very well read. It's not that he was disinterested in knowledge, but he just wanted to get going. He was ready to do this thing. He established his first company, his very first company, in 1958. When he was 18 years old. He was born in 1940. That was what he called C.M. Sinclair's Micro Kit Company. This is a period of time, we have to remember that both in the United States and in the United Kingdom, there is a growing interest in electronics as a hobby. This really, in large part, came out of World War II. Now, there were amateur radio enthusiasts, going all the way back to the 20s. It's not like amateur electronics tinkering originated with World War II, but there were so many electronic devices built during World War II in service of the war effort that were then discarded en masse when the war was over to end up in surplus shops and junkyards and God knows where else. That there was a new generation of children, and that were by the 50s, of course, becoming teenagers, that had unprecedented access to electronic components. And, of course, electronics are developing very rapidly in this period. The transistor is developing rapidly. The integrated circuit is just around the corner. So it's a time when electronics are growing. It's a time when more and more people have had exposure to electronics, and you see a real burgeoning electronics hobby. It's still very much a niche hobby. It's fiddling around with an amplifier isn't replacing football as the national obsession anytime soon in the United Kingdom. But it's definitely a growing hobby. So you have magazines that cater to these people. You have a lot of technical manuals being written or instructional manuals being written. You have a lot of people that are interested in sending away for electronic kits of various kinds to build their own little amplifiers or radios or, just about anything else that's out there. So that's the world that Clive Sinclair is getting himself into in 1958 when he establishes this company. His goal is this miniaturization thing. His goal is to push circuit design forward. But he's a poor student. It's not like he's founding this company with investment capital or partners or a rich family that is funding his every whim. From the very beginning, we also see the other thing that defines Sir Clive throughout his career, and the thing that will quite frankly come back to, quite frankly, bite him in the ass on more than one occasion.
Wouldn't it be bite him in the arse?
I suppose. Bite him in the arse on many, many an occasion, which is that he's looking for the best deals he can get on electronics, on electronic components, on things like transistors and capacitors and batteries and anything else. He's always looking for the deal, whether that means buying in bulk, whether that means buying pieces that are slightly flawed and not up to spec, but still technically work. He's always looking for the best deal. He's looking for closeouts. He's looking for overstocks. He's looking for rejected pieces that, like I said, have been rejected because they don't meet spec, but that doesn't mean they're totally broken. We're going to see a lot of hodgepodge electronics put together by Sir Clive throughout this period. This first company really doesn't get off the ground very well. He has a design for a transistor radio that he's put together, for a miniature transistor radio, of course, smaller than the norm. That's his thing. But he can't get anyone to back his designs, at least at first. So he supplements his situation by serving as an editor and technical writer for some of these technical magazines and technical publications and manuals that are proliferating in this period. The same year he establishes his first company in 1958, he also becomes an editorial assistant at Practical Wireless, which is one of these hobbyist magazines, obviously for people that are enthused about wireless communication primarily, but all of these magazines start expanding into wider realms of electronics as well. So that's a pretty sweet gig for him. He basically spends 1 day a week on the job. I mean, it's a full-time job, but the work only really requires 1 day of attention a week. Articles are submitted by enthusiasts. He goes through the articles. He picks out the ones that he thinks looks good, gives them a bit of editorial polish, and arranges them for publication. So he has a lot of time to tinker with circuits. From there, he ends up moving on up. He gets recruited by a publisher of technical books, technical manuals and journals named Bernard Babani, who recruits him out of there to basically run his publishing company. Now, this isn't some huge publishing company like Random House. Still, he takes over at the end of 1958, so he's not with Practical Wireless very long. He takes over this publisher, which is called Bernard's Publications, named after its founder, and spends the next few years serving as the head of this small publishing company and also being the primary writer of its technical manuals. So we can see he's one of these guys that's kind of at the intersection. He's definitely more on the technical side than the humanities side, but he's one of these people that does have some left brain and some right brain skill, which is important if you want to be a budding entrepreneur. He does this for a couple of years. He wraps up the first company, which never really got going. Then in July 1961, he establishes the first company that he'll truly be associated with and that's truly important, Sinclair Radionics. Kind of a weird name. The reason he came to that is basically he wanted to call it Sinclair Electronics. There was already a Sinclair Electronics, Sinclair being a fairly common name. Then he thought maybe he'd call it Sinclair Radio because that wasn't taken, but he just didn't like the way that sounded. So he decided to combine the words radio and electronics and came up with the new word Radionics. He has the company. He has a transistor radio that he wants to sell. He can't get a backer. One guy almost backs it and then pulls out. Again, he's not getting much of anywhere. But during this exact same time period, he is asked by Bernard's to do a survey of the entire nascent transistor industry that is being published by the company. So he goes all around Britain and learns about all of the companies that are getting involved in this new field. Now, the British companies in general are a little behind the American companies in this period because the transistor was invented in America. I mean, that's where a lot of the early advances were done at places like Fairchild Semiconductor and Texas Instrument. There was one very interesting company that he discovered by the rather unimaginative name of Semiconductors Limited. It was established as a joint venture between a British company called Plessey and Philco, which was one of the early transistor companies in the United States. Plessey basically provided the real estate and Philco provided the know-how. Semiconductors Limited was working with one of the more advanced processes at the time. They were one of the more advanced British companies, but they had very low yield rates of only between 20 and 30% on their most advanced semiconductors.
And that's on the wafers themselves.
That's correct. So when we're talking about yield rate in the transistor industry, in the semiconductor industry, basically when you have a microchip, one of those tiny little microchips, that microchip is not created all by itself on the assembly line one at a time, making each microchip. You actually create a whole bunch of microchips all at once on one giant piece of silicon called a wafer. Then you actually cut the individual chips out of that wafer once it's gone through all of the chemical processes that etch out all the layers and create all the pathways, and voila, microchip. When they speak of yield rate, what they're speaking to is of the individual chips on a single wafer, how many of those actually work right, how many of them are up to spec. That is the yield rate. There's virtually never an 100% yield rate, just because it's very complicated chemical processes done on a very, very, very micro/nano level. It's just impossible to get the perfection needed on every single part of that wafer. In general, when you have a new chip, yield rates tend to be very low, which is why it's very expensive to invest in a new piece of technology, because the processes haven't been tweaked and perfected yet to get as much performance out of that manufacturing process as possible. So yield rates go up over time, and generally on successful chips get very good by the end, but they tend to start low.
As low as 30%. I didn't know that.
Yeah, at least in this case. Now remember, this is very early days. I'm not an expert on the modern semiconductor industry. I would be shocked if chips start with such a low yield rate anymore. We're talking very early days, very primitive tools, and people basically inventing the chips and the processes at the exact same time. Yeah, this chip was coming out with a yield rate between 20 and 30%. What Sinclair discovered is that actually the majority of the chips worked. It's just that process I talked about before, where they didn't meet the specs that the company had for the device. And of course, if they don't meet spec, you can't sell them, because if you're a manufacturer and you're selling a chip to somebody and the chip is supposed to be able to do this, this, and this, if you sell them chips that can't do that, then you're basically defrauding your customers. But just because they don't work for what Semiconductors Limited wants to do doesn't mean that they don't necessarily work at all. Clive made a deal with the Semiconductors Limited to buy by the thousands these flawed chips at a very cheap price, and then he just designed his circuits to work within the confines of the flawed chips, because he's making custom stuff for hobbyists. I mean, if he were a defense contractor, that would never work, because they need consistency, reliability, dependability. But he's just making stuff for the hobbyist market. He can build whatever darn circuits he wants, and it's not going to be the end of the world if something doesn't work right.
So if I understand correctly here, he'll take a chip from here that's flawed, and let's say that it can do addition, subtraction, multiplication, and division, and it has those commands in it. Spec is that it can do all four of those. He gets it, and it goes, well, I can only do addition and subtraction. He goes, okay, I can still do something with that. He takes it, slaps it into his circuit board, and goes, I'm going to just do addition and subtraction here as my basic calculator to teach little Johnny how to add and subtract. Done.
Right. I mean, at this point, he's not making calculators. It's a good analogy in terms of, yeah, maybe the functionality is not all there, but, there's still something he can do with it. He took these flawed transistors, designed a miniature radio that would work with these transistors that was so small and so power efficient that it could literally run off of a hearing aid battery. which again cuts the price, then began selling this product in around 1963, and that was his first hit. He had put out a couple of products before that. He had a micro amplifier that he was selling starting in 1962, which was his very first product. The miniature transistor radio was far and away his first hit. It was the product that established the company, and also that year he stopped working for Bernard's and just started investing full-time in his hobbyist company. We've seen that he does the miniaturization, and he does very good circuit design. The flaw in what he does is, well, really there's two flaws. The first flaw is because he's taking product that is remaindered or defective or in some other way not working perfectly right. It means that his sources may eventually dry up. It's not like he's buying his product from the catalog. For instance, with Semiconductors Limited here, as long as their yield rates are super low, this business model works because they'll keep funneling him these cheap transistors. But if their yield rate ever improves to the point where they don't have a lot of defective chips anymore, then even though the company still offers the part, his supply has completely dried up.
Or his costs have gone way up because then he can still probably do it with the same chip that works. Right. But instead of it costing him, say, 10 pence, it cost him 10 pounds.
Exactly. So it blows up the whole model. So that's the first problem. The second problem is when you're working with defective product, even if it's defective product that still technically works, that means that some of that product you're working with is actually not going to work the way you think it is. You'll see a pattern with Sinclair products that they become well known for their questionable quality. This is something that dogs Sinclair throughout the 60s and 70s, and in some ways even into the 80s with the computer stuff, but especially the 60s and 70s. The company's known for having really cheap electronic kits that are really small and really efficient compared to what other people are doing because he's such a good circuit designer, but that maybe won't work right out of the box. Now, Uncle Clive himself knew this, and Sinclair had a very liberal exchange policy. Basically, if you got a kit and it didn't work and you sent it back in, you would get a new one, no questions asked.
So he loses out on shipping, but it's all good.
You know, this is a hobbyist market, so a hobbyist market is a little more lenient when it comes to that kind of thing. We're going to see this get him into some trouble in just a little bit here, but in these early days with a hobbyist market, the fact that people aren't expecting miracles anyway, that they're just kind of messing around and having fun, and the fact that they know that they'll always get a working product eventually, even if they have to send back for it a couple of times, means that this kind of goes along. So he sets up shop in London. He's a very small operation. He doesn't do his own manufacturing. He actually contracts with a Cambridge company called Cambridge Consultants Limited, which had been founded in 1960 by a chemical engineer named Tim Iloart. If I'm saying that right, it's spelled Eiloart, so Iloart, or however he spells it. This Cambridge Consultants Limited was a company that was specifically set up to harness the talent of Cambridge students and recent graduates in order to provide contract electronics production, design, and manufacturing to other companies that may need it. Cambridge is the technical school of Britain, the science school of Britain. It's kind of the MIT of Britain, essentially. There are two major universities above all other universities in Britain, Oxford and Cambridge. By tradition, Oxford is the school you go if you're really into the humanities, and Cambridge is the school you go to if you're really into science or mathematics. Isaac Newton, Cambridge, Stephen Hawking, Cambridge, and many, many, many other fine British scientists as well. This was kind of the beginning of what became a very thriving Cambridge technical business establishment. This guy, Iloart, by establishing a company that kept bright young electrical engineering students and electronics experts in the Cambridge area after graduation, then these people would go off and make their own companies, or other people that graduated would form their own companies there because there was already a base of tech companies there. This is kind of the beginning of a flourishing Cambridge electronics scene, which will become very, very important to not just the history of British computing, but the history of all computing, because as we've talked about before, Acorn Computers, which is a company that we'll be talking about in some depth in the second part of the episode because of how they relate to Sinclair. This is a company that eventually creates the Acorn RISC machine, or ARM for short. I think we all know the ARM processor.
Oh, we do know the ARM processor used in all of our loving cell phones.
Exactly. So that's a bit of a long-winded way of saying that Cambridge is becoming an important center for electronics, and Sinclair is actually contracting with a company there to do the manufacturing and all of this other stuff, even though his company at this point is actually in London. There's one other person that I want to bring up in these very early days. We're not going to talk about everyone who ever passed through the doors of Sinclair Radionics. It remained a small company throughout most of its history, so it never had too many employees. But kind of one of the first people that Sinclair brought on to help him with things was a gentleman by the name of Jim Westwood. Westwood himself was a hobbyist, actually ended up working as a clerk at the electronics shop owned by the Bernard Babani, who owned the Bernard's publishing house that Sinclair had worked for. In addition to having that publishing company, he also had an electronics shop of his own that he was also heavily promoting. Because of that connection, Jim and Sir Clive got to know each other. Sinclair was looking for someone to help him build his designs. Jim, being an enthusiast with electronics, really would have preferred to be involved in actually working with electronics rather than clerking at a store. So it was kind of a match made in heaven. And so in September 1963, Jim Westwood joins the nascent Sinclair Radionics company. For the next few years, basically the way things would go, and obviously there are exceptions to this, but the basic flow of things at the company at this time is that Sir Clive would design all of the circuits that they were going to be using in their products, and he'd put together the schematics on how everything worked. Then it would be Jim Westwood's job to essentially be his technician and then go off and actually build the product, make sure that the product actually worked the way Clive intended it to work, or at least worked the way he intended it to work enough of the time that they could stay ahead of the returns. Just generally put all of Clive's ideas into practice. This was kind of a good, solid partnership that allowed the company to grow at a very nice rate throughout the 1960s.
That is actually something that's very true for most successful tech companies. You have the ideas man, Clive, who comes up with the thing, and you have a really good person who can actually implement that idea at a market level.
Absolutely. Sir Clive is a little different from some ideas guys. Unlike, say, a Jobs-Wozniak pairing, for instance, at Apple, Clive could really do all of the work. It's just that if he is both designing everything and building everything, then that takes away valuable time when he could be designing the next big thing. They're both technical people. You're absolutely right that Clive is also the ideas guy. Though Jim occasionally has his own idea as well. We shouldn't relegate him to mere servant. Yeah, you have Clive kind of defining the product, defining the circuits, and then Jim turning that vision into a reality. They get involved with amplifiers. Again, miniaturization of amplifiers. They come up with an amplifier called the X10 in 1964, which ends up being a disaster because it never quite works right. There's that Uncle Clive magic again. But people were so enthused because the intersection of size, power, and price on this thing was so brilliant that it got people very excited. So they actually got their first industrial contract to produce test equipment, vibration test equipment for an aircraft equipment company. Even though the X10 didn't end up working out, they got this big contract, which helped them a lot. They did release a follow-up amplifier that actually worked much better. So that got them business. Then they did a miniature FM radio, which was a fantastic seller for a time. By 1966, the company was making about £100,000 a year, which was absolutely nothing to sniff at for a small hobbyist tech company. I mean, that was very good. And that was also the year that they moved to Cambridge. So they were contracting with a Cambridge company. They had so many close ties with Cambridge. Cambridge was becoming kind of a center for the electronics industry. So in 1966, they ended up moving there and would remain there for the rest of the company's existence. 1966 was also another watershed year because in this period of time, the electronics market was changing. It used to be that electronics were really just something that was of interest to a hobbyist crowd. Obviously, every family had their radio. By the early 60s, more and more families had televisions. But televisions and radios were seen more as pieces of furniture than they were electronics. It was an appliance you had around the house. It was a piece of furniture you had around the house. You didn't really think about what was going on inside that contraption. You just knew that you had it and you turned a dial and it maybe worked, or maybe you adjust the antennas a little bit to the right and then a little bit to the left. And then if you stand perfectly balanced on one hand with one hand, a one-hand handstand exactly on top of your television and don't ever move, you'll get that perfect reception. But nobody was thinking about how it worked.
But I thought you just took your kid, had them have some tinfoil hat, and had them stand in the corner while you sit there, and then you have the other kid go over and train to dial for you.
That's right. Kids today have it so easy with those high-definition signals and television remote controls. In the 60s, with advances in audio technology and with the increasing interest in sophisticated rock and roll records, stuff by bands like the Beatles that did a lot of experimentation with different types of sounds and instruments and acoustics, you got a great deal of interest for the first time amongst the general public in high-fidelity stereo systems. Something that would have in the past really only been considered important by the most intensive audiophiles was now something that was being generally recognized as something that maybe not every family should have because they're still expensive, but that the discerning music connoisseur of the swinging 60s should not be without. So the demand for hi-fi equipment for things like amplifiers and speakers and tuners and all of these other components that were generally just limited to a hobbyist kit crowd before were starting to show up as fully assembled devices that you would go down to buy in the shop. Stereo systems back in this time period were not standardized. I mean, today the stereo really of any kind is kind of a relic of a bygone age. If you grew up in the 2000s, the stereo was something that was often even all of one piece at that point. You know, you had your tape players and your CD player and your tuner and everything and your speakers, but it was all kind of this single package. Even if you had a more expensive system that had individual components, that was still something that you bought as a set. You just bought a stereo, everything from one company, one standardized thing.
Very much like the Magnavox thing that we've talked about in the past with this centralized piece of furniture that is just, here's your radio, it has some speakers in it, it's got a tape player, it's got a record player in it. It's all one unit, usually a fixture-piece furniture.
Yeah, exactly. But in the early days, building your own hi-fi stereo system was in some ways similar to the people that build their own computer systems today. Now, you're not fiddling around with mounting the CPU yourself or mounting the RAM yourself, not at that level. But you would choose this record player over here, and this tape deck over there, and this set of speakers over here, and then you would plug them into each other using the varieties of cables used to plug all of these devices together and put a stereo system essentially together yourself. Again, you could still buy a complete package from an electronics store or an appliance store or whatever, but there was a lot of this do-it-yourself where you weren't soldering the boards anymore, you weren't creating the electronics, but you were mixing and matching various parts to create a stereo system.
So I would go out and buy a quote-unquote case for my computer stereo system. I then go, okay, into here I want to have my CD-ROM drive, record player. I want to have my CPU, motherboard stuff, i.e. radio, or mixer
or the mixer.
whatever. I just put all of these together and then hope that they all fit in the case correctly because I'm building this myself.
Exactly. It's kind of similar in concept, even if it's not perfect analogy and execution. With ordinary people becoming interested in hi-fi equipment, Sinclair having been involved in sound devices, whether those be radios, tuners, amplifiers, etc., from the earliest days, in 1966, they also get involved in the component stereo business, and they actually start creating fully assembled stereo components that they start selling in retail locations. Up to this point, they've been entirely a mail order company. It's a hobbyist company. Here's a catalog or here's an advertisement in a hobbyist magazine. Write to this address with your check, say what you want, and we'll send you the thing. Mail order. Now they're getting involved in retail as well. The company's doing well enough that they can do this. They really start focusing more and more on this, especially because kind of in the 1967-1968 period, they actually have to retire some of their more popular designs because of what we talked about before, because he's using these parts that he's cobbling together from everywhere where he's trying to get the cheapest price, the cheapest connect he can find. So they just got suddenly hit all at once by a wave of products suddenly becoming unavailable, components suddenly becoming unavailable because the sources dried up. They had to discontinue the FM radio, which was very popular. Their first stereo system that they built, which was also fairly popular, they had to discontinue it because they could no longer get the components. They brought out a new amplifier, and wouldn't you know, it was another one of these faulty Sinclair products. So their kit business hit a real snag in 67 and 68. In this time period, they transition to, instead of doing stereo kits, instead of doing radio kits, they're going to start selling stereos through electronics retailers. The hobbyist side doesn't completely go away, but we're seeing something different. We're seeing an item that is going to be offered at retail.
Therefore, that can command a higher price. Therefore, he can put more quality components in it. Therefore, he's moving up in the world.
Sure, in theory, though, even though you're correct that he's moving up in the world and that things will by necessity be more expensive because they're fully assembled, it's still Sinclair. He still has that same mentality. He's still a hustler. He's still making stuff that is going to work a lot of the time, but isn't going to work all of the time. And again, this isn't because he's incompetent. It's not that he couldn't build a product that worked all of the time. He was insistent on being one of the cheapest providers on the market while still providing innovative technology. That's the key here. He doesn't want to produce a cheap knockoff. He wants to produce a cheap cutting-edge product, which is not easy to do.
There's a traditional thing in marketing where you have a triangle where you can have something good, fast, and cheap. Typically,
yes,
you can only have one of those. Sometimes you can finagle two. So he's trying to go with cheap and good-ish.
Yeah, he really is. It's a challenge. The other thing is that he's most interested in dreaming up the next thing. When he comes up with a circuit design, or when he comes up with a product, or if one of his people comes up with a product to use one of their circuit designs, he wants to do that product, get it done, and then immediately move on to the next thing. He wants to be constantly innovating, constantly learning, constantly improving. This means that he's not the biggest proponent of QA.
QA, for those who don't know, is quality assurance. This makes sure that that little doohickey does what the doohickey does. It does what the thingy does. It doesn't say, for instance, turn into gremlins and then lead onto a rampage across the world. No, it continues to do its thing of make sure the gremlins die.
Exactly. So there was no quality assurance department at Sinclair. There was no extensive testing of product at Sinclair. I mean, you have to test a little bit even as you're building.
Does it turn on? Yes? Good. Out the door. Does it turn on and do the thing it's supposed to do? No? Throw it out the door anyway.
Right. So they do the bare minimum amount of testing of product. The other thing is, because he always wants to improve, is they will always be changing products even after they finish them. They'll do a little tweak here, a little tweak there. They don't have a QA department, and they don't have internal manufacturing. They work with contract manufacturers. They're constantly sending little tweaks and little updates to existing product to their contract manufacturers without any QA people to smooth over the process and explain to the manufacturer, okay, we've changed this, so you need to do this slightly differently, and let's make sure we go through this with you to make sure that your people understand all the steps. No, they don't do any of that. So their manufacturers are often left doing things the wrong way because Sinclair never bothered to tell them that they need to do things a different way. So Sinclair could have created products that weren't so finicky, that didn't break so often. He had the talent, he had the ability. He just didn't care. That wasn't his priority. So that does start to change a little bit, but only a little bit, at the beginning of the 1970s, when Sinclair gets into the business that really actually puts them on the map for the first time. The product that sets Uncle Clive Sinclair on the road to becoming Sir Clive Sinclair. That is the pocket calculator. We've talked about the calculator boom and bust in vague, well, not vague terms, but in general terms a couple of times over the course of the podcast because, of course, the early video game systems, as we've talked about, exist on a consumer electronics continuum that includes other products like calculators and digital watches. We've talked about how miniaturization and integrated circuits and then ultimately microprocessors allowed big desktop calculating machines that cost $500 to become small handheld machines that by the end of the boom are retailing for as low as $10. What we have not talked about is Sinclair's very key role in this process. Sinclair did not create the first handheld calculator. Texas Instrument created it, and the first handheld calculator widely marketed was by another American company called Bomar. These early handheld calculators were handheld calculators in the same way that early laptops were portable computers. Obviously, they are much smaller than an early laptop, which was the size of a small suitcase. But what I mean by that is you could hold an early handheld calculator in your hand while you were using it. But it's not what we think of as a handheld calculator today. It's not something that you could put in your pocket. It was handheld calculator, but it was not pocket calculator.
But it is definitely something that you would see as a smaller calculator than a actuary or in an office setting.
Right. Uncle Clive is, of course, very well dialed in to what's going on in calculators because he's dialed into everything that's going on in electronics. So when he sees these first handheld calculators, the first thing he thinks to do, because he is Clive Sinclair, is, I've got to make this thing smaller. That's his thing. He makes things smaller.
And better.
Exactly. So he decided that he was going to design, and have his people design, a calculator that could fit in a person's breast pocket. Back in those days, engineering types still generally wore Oxford shirts, collared shirts. That was kind of the IBM way of looking professional, and everyone else copied IBM. You would have an Oxford dress shirt that you were wearing. That Oxford dress shirt would have a chest pocket. This is where you would keep your important engineering tools, some pens, some pencils for sketching, your slide rule in the day before calculators.
And a pocket protector.
Yes, a pocket protector to make sure that those pens you're keeping in there don't spill everywhere because you don't have widespread ballpoint pens at this point yet. He wanted a pocket calculator because there was actually some practical use to a pocket calculator because this meant that an engineer could always have a calculating device in their breast pocket. Jim Westwood and another guy that had recently joined the company by the name of Chris Curry, who came to Sinclair after years of working in the defense electronics industry, together designed a calculator called the Executive. That's how it was marketed, the Sinclair Executive, that was released in 1972 and could fit in a pocket. I'm not an expert on the calculator industry. It may be the first pocket calculator. As someone who has studied the video game industry very closely and knows that the things that are commonly considered firsts in video games are often not actually first, it would not surprise me if the Sinclair executive was not the first pocket calculator, if someone somewhere created something before that. Even if it wasn't the very first, it was the first one that was produced, mass-marketed, and was accepted by the general public.
It popularized it, if nothing else.
Exactly. The way they were able to do it is actually kind of clever. I mean, obviously they had to do a lot of clever tricks to get the technology down. Kind of one of the last hurdles that they faced was power. You've got to have a power source, and at any given period in human history, there's only so far you can miniaturize your power source. I mean, just like every other electronic, not even really an electronic per se, but just like every other thing involved in electronic design, power supplies and batteries and everything else have gotten smaller and more efficient over time. But at any given moment, you have to work with what you can work with. And the types of batteries that were powering calculators in 1972 were just too big to fit in a pocket form factor. So they went back to their tried and true Sinclair method of hearing aid batteries. The problem with the hearing aid batteries is that they're smaller, but they are also weaker. They don't hold as much of a charge. They run out faster. They got the hearing aid battery in there just fine, and it ran the calculator just fine, but the battery ran down so fast that the calculator was essentially useless. So what they did, and this is very clever, I'm not an electronics person, but this sounds very clever. They realized that the capacitors that they were using in the calculator would hold a charge for 5 seconds, which means that after you turn the calculator off, it will still fully function for 5 seconds until such time as that capacitor is fully drained of its residual charge, at which point the calculator actually shuts off. So what they did is they actually had the calculator, they built in a functionality within the calculator that it would turn on and off rapidly during the period of its operation. This drastically reduced the power consumption, but because the capacitor holds a charge for 5 seconds, it appeared to the user that the calculator was always on. I mean, it always had power. But by rapidly turning it on and off, they got the power consumption low enough that the hearing aid battery worked without running it down. Clever little hack there, I think.
Do you have any idea how long the battery was lasting before this hack, or how long it lasted after?
No, that information is probably out there, but that's not something I have in my sources. I just know that that's how they reduced the power requirements. The calculator business comes along just as their hi-fi business is failing, because the market's getting more crowded, the consumer is getting more sophisticated, and quite frankly, the do it cheap, do it quick and dirty approach of Sinclair is starting to fail in the hi-fi market, which is becoming more high-end. But now the calculator is here, and boy, does that calculator just completely allow the company to take off like a rocket. They do establish a QA department, because at this point they're exporting to the US and Japan as well as selling in Britain. They're becoming a true international provider. It's one thing to tell a British consumer to just put your device in the post and we'll get you a new one. It's a completely different thing to tell someone in California to put their calculator in the international post and we promise we'll get you a new calculator someday. They get a little less sketchy in this period. They get some QA going. It's still Sinclair. It's still quality that sometimes there, sometimes isn't. But they're trying a little harder. Then in 1974, they produce what may well be, again, I don't research calculators well enough to know for sure, but this has certainly been claimed. They release what may well be the first single-chip scientific calculator that can do scientific functions. The Cambridge Scientific is what they call that one. They use the Cambridge name instead of the Sinclair name because it's Cambridge, it's the science capital of Britain. This calculator is also a massive success. In 1973, the company had sales of 762,000 pounds. In 1974, the year they introduced the scientific calculator, those sales grew to 4 million pounds, an over four-fold increase in sales over the course of a single year.
That's quite the jump. That can either really accelerate a company or destroy it.
At their height, they were shipping 100,000 calculators a month. A month. So, of course, with all of this money coming in and all of the success, it was time for Sir Clive Sinclair to turn to his neatest idea yet.
Digital watches?
Yes, digital watches. I knew you'd catch that.
If all of our British listeners haven't gotten that one, I have a book series you need to read.
Absolutely. So, of course, as we talked about before, after the calculator, kind of the next big thing was the digital watch, which really was something that was considered an incredibly neat idea. I mean, there's a reason that Douglas Adams parodies this, because people did for a brief period of time go digital watch mad. Even a couple of years before the scientific calculator came out, even as early as about 1972 or so, he was starting to think about getting into the brand new field of digital watches. So, of course, again, he wants to make something smaller, cheaper, better. So he comes up with a very simple and cheap watch called the Black Watch. It's called the Black Watch because it's all black. It's a plastic case, all black. It's an LED readout. Early digital watches, and this definitely qualifies as an early digital watch, did not use LCD technology, which hadn't quite gotten to the point where it was viable yet. They used LEDs, light-emitting diodes. But because the technology of LEDs was so new in this time period, and because they were so power-hungry, because they were so new, when you had a digital watch in the early 1970s, it isn't like an LED watch that you would wear in like the 1980s, where you just look at it and all these pretty LEDs tell you the time. No, you actually have to press a button on the watch to cause the time to show up. The reason for that is just it's too power hungry. If you had the LEDs on all the time, you would drain your battery in minutes. Then it's no use as a watch.
Think about how it is today with smartwatches.
Mm-hmm.
With many of those smartwatches, they go into a power save mode in order to preserve battery power. You have to press a button, or it has some sort of motion sensor where it goes, hey, you wiggled your wrist, therefore I know you're trying to talk to me, therefore I will turn on. If it had that full screen, full brightness running all the time, that battery's going to barely last a day, if that.
Exactly. It was the same with very early digital watches. So it was a simple 3-button watch, and you pressed a button, and I think there was orange LEDs kind of in this one. I could be wrong. Might have been red.
Probably red.
But you had a red LED kind of display. You know, it would tell you the time. That's all great in theory. In practice, we had a little problem with QA. Because as we said before, Sinclair is not the biggest fan of testing. Now, they did test the Black Watch, but they did not do environmental tests.
Environmental test?
Yes.
Well, presumably, it's in an environment where it's on my wrists. I am having a wonderful stroll in the country until it started raining.
Right. So they actually tested it in winter because that's when they were in that part of the process. Winters in Britain are very cold and very damp. So the conditions that the watch were tested in were very cold and very damp.
That sounds like a good place to have testing because I'm going to have moisture in a lot of different places. I'm going to have it cold and have temperature extremes. I'm going to be going from the inside of a building to outside of a building. So I'm going to have cold weather outside, warm weather inside. Sounds like good testing to me.
The problem is, electronics do operate differently in different conditions. And it turns out that if you're in a hotter and drier environment, you are more susceptible to have a problem with static.
Oh, so a static shock.
It turns out that this static shock could fry the chip in a way that made it stable instead of unstable the way it was supposed to be.
Fry the chip as opposed to the crystal that has the timer?
Right. So what this would do then is cause the crystal to stop oscillating. When the crystal stopped oscillating, it would stop keeping track of the time. It would freeze. When you press the button, you would only get a single digit that would show up and nothing else because it was completely frozen. But wait, kids, there's more.
How can it be more? It's already broken. It's not like I can reboot this thing.
Because when the crystal stops oscillating, the battery ends up in a perpetual on state. When it freezes, you don't even have to press the button. When it freezes, the single number appears on the screen, period. Which means that the battery is in constant operation.
So the battery dies really quickly.
Oh, we're not just talking about dying, because good old Uncle Clive is using his good old hearing aid batteries again, which really aren't meant to have that much power coursing through them. The batteries would overheat.
Overheating batteries, as we have learned from lithium-ion batteries on so many occasions recently, go kaboom on my wrist.
Exactly.
And I kind of need my hand for typing.
So not every single defective black watch would explode because the battery did not overheat in every case. But there were black watches that literally exploded.
That's not good, kids. That's not good.
This black watch was an absolute unmitigated disaster. There was just no way to sugarcoat every way that the black watch was bad. And of course, the name becomes so unfortunate because black is associated with death and funerals and decay. And so the very name takes on a whole new meaning with all of the horrible defects.
You don't want to wear that thing anymore unless you quite literally have a death wish.
It very nearly sinks the company. Not only is it defective, because of delays with the chip suppliers and with the manufacturing, it didn't come out until 1975. By 1975, the digital watch market is already saturated and is starting to decline anyway. It would have been challenging even if it worked perfectly. And of course, as we have just seen, it did not. This is the same time the calculator market is on the verge of collapsing. The calculators have been the bread and butter. They still have other things as well that they're in. They're still in stereos, even though that's a little shaky. They're still in instruments, testing equipment and whatnot, and that business is actually doing pretty well for them. So they're not going to go under tomorrow, but they're in very bad financial shape. Sinclair decides that the future of the company and of electronics is going to be in television. Now, obviously, television is not a new thing in 1975. He's looking at two different things. For years now, literally almost a decade, he's been trying to get a miniature, always miniature, television with a 1-inch screen called the Microvision off the ground with a really tiny screen.
Why would he want that?
Because it's portable, because smaller is better. Because this man is obsessed with smallness. I'll leave that one to the psychologists. But at the same time, he's decided that the future of television is going to be in flat panel displays.
That is true.
That is very true. He's a bit early. A bit too early. A great idea, but you got to build these things. So he's got an idea. He's going to try to get these small TVs, but he's also got this idea for a flat panel TV as the future of television. The problem is the company's losing money. Nobody is going to invest at this point. He can't get any more loans from banks. He can't get lines of credit. Venture capital, as we know it in the U.S., doesn't really exist in the United Kingdom, so that's not even an option. He ends up selling out to the government. The National Economic Board. You have to remember that Britain is a more socialist country than the United States is, for instance. I don't know much about the British socialist system of government, so I don't want to go into depth on this and start claiming things that are not true. But just on a macro level, let's just say that government participation in private enterprise is less unusual. It's still not the norm, but it's less unusual in the United Kingdom than it would be in, say, the United States. So the National Economic Board has money because it's a government entity. They would at times invest in companies that they thought were promising but didn't have enough capital. with the idea that they would get a good return on investment. And so everyone prospers because the entrepreneur gets an influx of money from the government gets that money back in profits, yada, yada, yada. He actually sells 43% of the company to the National Economic Board in 1976 for £650,000 so that he can start this television research and development in earnest. Unfortunately, right after he makes the sale, the bottom completely falls out of the calculator business. It was already declining, but now it's really declining. Sinclair becomes something of a victim of circumstance. Now, we don't want to take this too far because it's also true that Sinclair was not a management type. He wasn't one that was really adept at running a company, even though he's the one that ran the company. I do think the NEB had some legitimate concerns about Sinclair as a manager, even without that situation. But the fact of the matter is, the calculator market collapsed suddenly. There really wasn't much Sinclair could have done to prevent that. I mean, he was already trying to diversify out of calculators. I mean, it's not like he made a mistake of thinking the calculator market would last forever or something. He was already trying to diversify out. He just didn't have the capital. Because they took a huge dip in profits, the NEB lost all faith in Sinclair and ended up forcing an upping of their investment to 73% of the company in July 1977, which meant that they were now the majority owners and Uncle Clive was a minority owner. They could enforce whatever edicts they wanted. So Sinclair was sidelined. They brought in another manager to run the company. They didn't get rid of Sinclair. He was still in charge of developing the products and whatnot. But this started a great period of tension between the person hired to run the company, Sinclair, and the NEB that were in kind of this unstable tripod vying for control of the organization. The NEB kind of soured on the whole TV thing because they didn't think it was going to work, which, I mean, they were quite frankly right about just because it was too early. The technology wasn't there to make a consumer flat-screen television of any usefulness and affordability in 1977. There was just this big power struggle going on. Right at the start of this process, even before the NEB took their majority interest in the company, Sinclair kind of figured that things were going to perhaps get a little fraught. He created himself a lifeboat in 1976 after selling to the NEB. He took Chris Curry, who we mentioned briefly as the co-designer of the calculator, who had definitely emerged as his right-hand technologist, because Chris Curry was a brilliant designer and circuit designer in his own right. He had definitely become something of a protege/partner with Clive Sinclair and had become his most trusted employee, his most talented employee, I think it's probably fair to say as well. He co-founded a new company with Curry in 1976 called Science of Cambridge. So Curry stopped working for Sinclair Radionics and founded this new company. He had to take a 500-pound loan from his own father to set the company up and buy office furniture. They were literally starting with nothing. They couldn't use anything from Sinclair Radionics to set up this new company because the point is they had to make sure it was a completely separate company. Because if the NEB became too much for Sinclair to handle, too much for Sinclair to deal with, or if they tried to force him out, they needed to make sure that Science of Cambridge was completely pure, completely its own company, completely free of any connection so that Sinclair could just hop right into it and keep doing what he liked doing. Make sense?
Yeah, that makes sense. You don't want any kind of paper trail tying you back to Sinclair Radionics because the NEB could be, we paid for the office furniture. We have a say in that.
Exactly. They founded this little company. It was basically just Chris Curry. It was only Chris Curry at first. He came up with a wrist calculator design. It wasn't very good. It was kind of a cruddy product. It's just the way it worked out. I mean, it's no reflection on Curry as a designer. It's just it didn't end up being a great idea. He was looking around for what to do next. And at this point, he was approached by an individual named Ian Williamson. Ian Williamson was one of these hobbyist electronics guys. He had been paying very close attention to what was going on in the United States with the early kit computers, like the Altair. He was impressed by that kind of hobbyist community developing in the United States, and he wanted to try to replicate that in the United Kingdom. So he came up with a very simple computer design that he planned to build himself and start marketing himself. Well, he ended up getting a new job that was kind of too good an offer to refuse. So he decided not to go into business for himself, and instead to just take this design that he had come up with and show it around to a few different electronics companies in Britain and see if any of them might be interested. So he showed it to Chris Curry. Now, Clive Sinclair had no interest in computers. I said this before. He did not see that as the future. He saw the future in flat-screen televisions. He saw the future in digital watches. He saw a lot of futures. One future he never saw for whatever reason was the computer. Chris Curry, on the other hand, saw an opportunity because somehow through all of this, he had ended up with a bunch of surplus calculator parts, not just electronic components, but also displays and keypads and cases, all sorts of surplus calculator parts that had been part of Sinclair Radionics that were now worthless because of the collapse of the calculator market. And I don't know the story behind it, but for whatever reason, Clive Sinclair funneled a lot of these surplus parts to the new company, Science of Cambridge. So when Chris Curry saw this design from Ian Williamson, his first question was, could you do this using calculator parts?
Because I have a lot of those, and they're really cheap.
Yeah, because he needed to use them up, and he couldn't do another calculator. That market was dying. He saw this as an opportunity to repurpose those calculator parts to make a very simple kit computer. Williamson was like, sure, yeah, we can incorporate these. So he did a design incorporating these parts using a national semiconductor chip called the SCMP, which was often called SCAMP by, inserting a vowel in between those, SCMP. The SCAMP was one of the very early 8-bit microprocessors. It's one that didn't end up catching on very much overall. It was one of the early ones, and I think it was pretty low power, so that was desirable. They decide that they're going to use the SCAMP chip, and then when Chris Curry goes to National Semiconductor to negotiate purchase of the chip, National Semiconductor is like, oh, we won't just give you the chip, we'll give you everything. We can design something for you that meets your needs, and then give you the whole package. Even though it was Ian Williamson's idea to do this, Williamson's design actually gets sidelined. They don't use it. They use a custom design from National Semiconductor instead. So they released this in 1977 as the MK14, which stood for Microcomputer Kit 14.
So what happened to 1 through 13?
That is an excellent question that I don't know the answer to. I mean, obviously there were not 1 through 13. I don't know why they chose to append the number 14 to it. That was the computer, the MK14. We'll put this thing in the show notes. It barely qualifies as a computer. It is a computer. It has a microprocessor. It has RAM. It has I/O. It has power. It's a computer, but it's made of calculator parts. It's a kit, so it doesn't come with a case. It's just a board. It's a calculator-sized board. It has a 20-key keypad. It doesn't even pretend that it has a keyboard. It's a calculator keypad. You do all your programming in hexadecimal. It only an LED display, and it's a calculator-sized LED display. It's not even like a Mattel handheld size LED display.
But can we just supercharge this thing with 2 calculator displays?
It has 256 bytes of RAM.
That's bytes, kids, not kilobytes or megabytes or gigabytes or terabytes. Bytes.
Yeah, it could be expanded up to 640 bytes, not kilobytes, bytes. So there was not a lot going on there, but it was just something meant for hobbyists to play around with. Remember, this isn't meant to be a mass consumption kind of product. It comes with a book of 20 programs that you can type in. There's no ROM on board in the basic configuration. There's just the RAM, which means that every time you wanted to use one of these programs, you had to type it back in again. There were optional ROM storage options, like I said, it didn't ship with any disk or ROM-based storage or even cassette-based storage. Yeah, I mean, it has the distinction of being the first British homegrown microcomputer. It's the first microcomputer created by a British company sold to the British people. Of those 20 programs, 3 of them were games. I don't know what 2 of the games were, but one of them was Moonlander, which was a lunar lander variant. So these 3 games were the first 3 games designed for a British microcomputer by a British company. It gets a couple of firsts, but there's a lot to be desired. Nevertheless, the hobbyist community was so enthusiastic about being able to have an affordable computer kit. With all these drawbacks, the good news is it only cost you £40. The public was so enthusiastic about being able to buy a £40 computer that it actually sold really quite well for this type of product. It looks like it sold somewhere between 10,000 and 15,000 units. There are a few sources that put the number even higher. There's one source that claims 50,000. There's another that even claims 90,000. I don't think those are accurate. The sources closest to Sinclair and the sources closest in time to the events in question look like they've pretty much settled more on that lower figure of somewhere between 10 and 15,000. And that's really a more believable figure for such a limited piece of technology that's going to have very limited appeal.
Not to mention limited supply. Even though he has all these calculator parts, that is a finite resource.
Right. You know, that's really not bad for that kind of device, and both Chris Curry and Clive Sinclair take notice of that. Clive's still not a huge believer in computers, but he is a huge believer in selling stuff. I mean, he takes note of that, and he's like, okay, maybe there's something we can do with this. In the meantime, as this computer's being sold, things are going completely to hell at Sinclair Radionics. Again, we won't go into all the details. They get the small TV out. It kind of sells okay at first, but then doesn't really sell very well after that. Of course, the flat screen stuff really isn't getting anywhere fast. The instrument division is still doing well. Calculators are dead. NEB despairs of ever recouping their investment, which is a problem because there's some constraints on how they can do business as a government entity. They can't just run losses year after year after year. So NEB decides to finally wash their hands of the affair. They sell all the television stuff to Benetton, which is another British electronics company. They hold on to the instrument division because that division's still making money, so they're hoping that they can pull something out of that. They basically just shut Sinclair Radionics down.
Well, it looks like Uncle Clive needs that lifeboat now.
Exactly. So he certainly looks like a genius or very prescient for deciding that he should form this lifeboat company, Science of Cambridge. He moves over to Science of Cambridge and decides to put his full effort, his full future effort into projects at that company, which in 1981 he would rename to the name that it would bear for its entire life and the name that it is far more well known as, which is Sinclair Research. Needing products that are going to sell well to kickstart development, he's not the kind of guy that tends to pander to what the public wants. He likes to think he's one of these guys that sees the future and shows the public what they need as opposed to making what the public wants. Ever the realist, he does realize that he's basically starting this company from scratch. His assets are a mess after everything that happened at Sinclair Radionics. This MK14 thing did remarkably well. So even though he's still not a huge believer in the product category, he is going to get Science of Cambridge, soon to be Sinclair Research, started by diving even deeper into this new microcomputer industry. And that is where we will leave our story for now. It is the logical breaking point in the progression of Sir Clive Sinclair's career. Next time, we will pick up with the meat of the story and discuss that range of computers that in the early 1980s made Sinclair Research such a famous name and such an integral part of the United Kingdom's video game history.
Then we will go and do some research into the ZX Spectrum. Next time on They Create Worlds. Check out our show notes at podcast.theycreateworlds.com, where we have linked to some of the things that we discussed in this and other episodes. You can check out Alex's video game history blog at videogamehistorian.wordpress.com. Alex's book, They Create Worlds, the story of the people and companies that shaped the video game industry, Volume 1, can now be ordered through CRC Press and at major online retailers. Email us at feedback@theycreateworlds.com. Our Twitter is TCW Podcast. Please consider supporting us on Patreon at patreon.com/theycreateworld. Intro music is Airplane Mode by Josh Woodward, found at joshwoodward.com/song/airplane mode, used under a Creative Commons Attribution License. Outro music is Bacterial Love by Roland Music, found at freemusicarchive.org, used under a Creative Commons Attribution License.